Okay, this is Andrew McNamara with part 3. In the data queue message queue managers, I have a public enum for mode, normal, playback, and record, and that's how we switch off of the strategy. So in each message queue manager, they're pretty much the same all the way through. We have 2 protected queues, input and output queue, that can be used. All of these are private queues for the message types, which we initialize to low message numbers. These ones are just empty because they're empty queues, but these we want to actually use for object pooling. Switch off of the strategy that's called in the mode. So we set p strategy equal to one of the 3, and that's the only switch statement we use based on that. Add to input queue, just queues the message into the input queue. Same for the output queue on both. Queue strategy just returns our strategy. Get message from the pool. This is part of our object pooling for messages, where we, depending on the type of message, we either dequeue it from the pool if we have a message available. If not, we create a new one. So what this does is it dynamically creates messages if the queue is empty. So if we sent 10, it's not really possible in one frame, but if we sent 10 collision pool messages, and we had another collision, we would technically create a new collision message, and then when this is recycled, the queue would hold 11 messages. So it dynamically resizes the queue as we use more messages than what we originally put in the pool, and that is for all of those. Same on client. And then return message pool. ToPool clears the message first, which clears all the member variables, and then switches off the message type to re-enqueue it back to the right queue, specific queue that it's using. And then we have process, which is just pstrategy.process out and process in. So depending on the strategy, these functions will have different things. So in our queue strategy, each one has a protected message num that each strategy above it, this is our base class, each strategy above it can use to track how many messages are being processed out. We also have a get message num, which returns this for the screen log, so we can show how many messages are being sent. And then abstract process out and in. For our normal queue strategy, which is what we're using normally, our process out, while there are messages, dequeues, and then switch on the destination, server, client, or both. If it's server, it'll enqueue it in the input queue on server. Client will send the message to the client based on the delivery method and channel. This is all entirely data-driven. And then both will enqueue it and send the message, and then also increment the message num. And then process in is just input queue. As long as there are messages, we dequeue and execute. Same thing over here, except for client and server are flipped. And then in the network manager, just to show, incoming messages are processed. They are deserialized and then added to the input queue. And then in game scene play, we are pulling the message from the pool of the message queue manager, setting it, and then adding it to the output queue for all of these. And that is the data queue manager.